Hey guys, welcome to the channel. Today we're working on a remote controlled antenna tuner that I'm building. So far most of the important parts I found at a Hamfest. These stepper motors I managed to find at a local Hamfest, and then this variable capacitor and inductor I found at a different one. And I ordered these pulley kits off Amazon. I'll put a link down in below the description of the video if you guys want to see what I used for it. But it came with both pulleys, the small one and the big one, and then the little belt to drive it. Now, because of the belt being as short as it is, I should have gotten one just a little bit longer. I have to mount the motor actually this way. That way the belt will actually fit. Let's see if I can get it turned so you can see it in the camera there. So that's what we're going to do there. I 3D printed these brackets for the motors as well as a bracket for the variable capacitor, and this is mostly just to give me some spacing so that the variable capacitor isn't right against this. So there are going to be some high voltages present on especially on the output of this feeding into the inductor. It's going to be an L style tuner. There will be the variable inductor will be parallel to the antenna, so it'll go from the feed point of the antenna to ground, and then the capacitor will be in series. So our RF will come in as a capacitor, and then the output of the capacitor will go to the high side of this, which will also go to the antenna. And this should allow us to tune a vertical antenna pretty much over the whole HF band. And I'll make another video later on showing how I decided to use this configuration, why I decided to go with that style of matching network. Now if you're matching a different type of antenna, it'd probably be beneficial to have a second capacitor in there and do more of like a pi style tuner. But for just a simple vertical, in particular a 43 foot vertical is what I'll be using it on, but it should also work well for a 33 foot. This is all that we'll need. So now that I have the brackets made up, I just have to drill the holes and mount these down. And for now I'm just going to try to put some little slots in the metal so that I can slide the motor to tighten it up, tighten the belt for each device. And then I'm going to come up with some type of tensioning mechanism, probably some type of like an idler pulley and a spring or something, just to keep tension on the belt so that as the seasons change I don't have to go out there and tweak the tension on it. But for now the idea is just to get it put together and working, and get it to where we can work on the firmware. So what I'm going to be using to drive this is this little board here that I found on Banggood, and I'll put a link below for that as well. It came with the Arduino Nano as well as the stepper motor drivers. It did come with 3 of them. I got the other one right here. I just did not install it because I'm not using it. But anyways, this is going to drive our 2 stepper motors, and then I'm going to have some buttons, some push buttons coming off of this, so you could manually control it with a push button if you want, but the goal is to have it remotely controllable. And that's what we're using this guy for, little ESP8266 module. So this will allow us to control it over Wi-Fi, using either potentially an app on a phone or a web browser interface. Or you could even use another ESP8266 to talk to this and have that run its own little interface. So I got a couple different ideas that I'm playing around with there. Part of the reason I wanted to do 2 separate things, because this alone probably, not probably, I know it could drive the stepper motors also. I could just totally get rid of this Arduino Nano and interface this to these. But kind of the purpose behind doing it this way is down the road, if I want to control it with some other radio protocol, maybe instead of Wi-Fi I want to use Bluetooth and put an ESP32 in there. Or maybe if I want to use LoRa, I can put a LoRa transceiver in here, or a little development board with a LoRa and its own microcontroller, and talk to it that way. So this thing will basically just be the motor controller and I'm going to talk to it over the UART interface with this board, and we'll get into that as the project progresses. But that's where we're at right now. So I'm going to getting these parts mounted, and then we'll be back with an update once we get that done. So our feed point's going to come in over here and connect to one of these terminals I put on this other side, and then over here there's the terminal for the other side of the capacitor, and that will connect over to the terminal over here on the inductor. I suppose I should turn that so the camera can see it. So we will have our RF input, our SO239. That'll go over to this terminal, and then from here the output of this will go to that, and those will go to our antenna. I'm trying to get these as close together as practical, so that this jumper between those does not have to be too long. I think right about there is going to be a good location probably. And actually I'm going to slide these forward. I want it probably all the way this way. That'll give me room back here, over in this area, over here, to mount the electronics. So I prefer to mount the electronics as far away from where there's going to be high energy RF as possible. They may very well end up needing to be in their own shielded enclosure. Ideally they would be. I think probably that's going to be good. Right there. That'll just take this over to there and then out to the antenna. So we'll mount these two pieces first. line it up and mark around the motor bracket that I made, and then I'm going to have to take the motor out and actually mark where the holes are, because I can't really get in there too well right now with the motor on it. I'm going to tighten these down so I can actually spin that a little bit and make sure that the belt is centered well. Right about there looks to be good. Alright. For this guy, what we'll do is we'll put it about halfway here. Right about there seems pretty good. Alright. Well, hopefully then maybe we'll get lucky and some of those will line up. This plate was previously used for a different outdoor device, and just kind of readapting it to this. Okay, we're back, and as you'll see in a second here, I have it running a small test program, just showing that both motor drives are working. Alright. So, we got it all mounted and electronics wired up, at least partially. I haven't added the ESP8266 in there yet, but at least we have the motor controller part working. There was some issue I had with the driver for the capacitor, and luckily I wasn't using that third board, so I just swapped that one and then it worked. So one of those motor drivers must have went bad. I don't know, maybe it took a static discharge or something. But anyways, now I'll get to writing the software to get the motor controller to do what I want, and then I'll be back with an update once I have that part working.